Hi everyone. So let's start. Today we are going to discuss about NPM security and dependency management things. So as we all know, Node.js is very common language, like very lovable language nowadays to build applications. But Node.js is very lightweight, and it totally depends on the third-party packages which anyone can deploy on npm.js. So what happens after some time that packages got vulnerable, that cause security issues. So we are going to discuss from zero, like how this vulnerability gets introduced, what are these packages, how those are managed, how versions are managed, and then uh, how we can avoid this security issues to come in our application, and how to audit our application every few months, so that we can figure out what are the vulnerable package and fix those. So let's start. In this session we are going to discuss from zero. So we are going to first understand what are these dependencies, how many type of dependencies, how packages and we are managing the versions, and then what is npm audit and dependency tree, and some live cases, and then we will discuss about how we can avoid this with the new node for 24 version with a configuration. So let's start with what are dependencies. So dependencies are of three types. As we know, node.js completely depends on third party packages which are on this npm site. So anyone can build a package and deploy it here, and we can directly use it instead of writing the code again and again. We can use this package. So this package is completely free of use, and anyone can use, and this can be maintained by the maintainer. But most of the times what happens, after a certain time, after certain years, the packages are not maintained, and those ports gets vulnerable. So let's discuss about what are these dependencies. So these packages are used in our code, but these are used in different ways. So there are three type of these dependencies: direct dependency, dev dependency, and transitive dependency. So I have created a small demo project so that we can understand these three different type of dependencies first. So first we can see here we have uh, direct dependencies like this axios package. We are directly using this axios package if we need to. This is very common package which is used to do a http request, like any rest api calling or anything. So this is used in most of the applications. So this is the package we are directly using in our application for communicating internal microservices or calling a third party API. So this is direct dependency. Then it comes the second type of dependency, that is dev dependency. So it is used by developer for the development time, like nodemon. Nodemon is a very widely used package which is used by developer at the time of development. It can restart the server without any manual work on any change in the code. So it is used for developer. This is not having any impact on production, but this is uh, dev dependency, and it is in our code. So it's vulnerable. If whenever it gets vulnerable, the code also gets vulnerable, and it can impact the production also. So we need to manage this also. So the third type of dependency is transitive dependency. So as we can see, we have only this 7-8 packages in our direct dependencies. We are directly using only this 7-8 packages. But whenever we see our package log JSON, we can see there are about hundreds of packages. Like for example, we can say there are 800 packages. So how this packages comes into our code? So basically, whenever we are using any of this package, it can be internally using any other packages. If we go on this site of npm, we can see the code of this axios package, and here in the package json we can see the its dependencies. So if I can show you here, we can see its dependencies are this four packages. So internally it is using these four packages, and we can also figure out in our uh, code like which package is related to which. So we can just use this npm ls command. We can see and follow redirect is the dependency of axios. So in this way it also comes in our code. So whenever a nested package gets vulnerable, it also impact our code because we are using it directly or indirectly. It will be in our code. So we need to always watch, have a watch on this, what are getting vulnerable. So yeah, this is are about transitive dependencies. Okay, so package JSON, like we can always maintain the version of a package. So as we can see on the all of these packages have multiple versions. So it gets upgraded by the maintainers. As we can see, this is having 1.8 18.1. So these packages are having major, minor, and patch version. So basically, all this we can control in our package JSON, like we need to upgrade or not. So basically we are having a caret symbol. So what this caret symbol do, it will, whenever we run a npm install, it will fetch the latest minor and page version. It will lock the major version, that if axios 2 is available, but it will fetch only axios 1, but it will fetch the latest minor and page version of it. Similarly, we have a tilde signal, tilde symbol like this. So it will log the major version, including it will log the minor version, but we can fetch the latest page version. And whenever there is no symbol, it will fetch the exact version which we are mentioning in our package JSON. So this is how these versions got logged into our package JSON. We can manage, we want to get upgrade or not. So moreover, like minor and page version never have breaking changes. So they do not have breaking changes. So those are safer to upgrade. So that's why majorly we people use this caret symbol, like whenever there is a minor and page version upgrade available, it will directly pull the latest version. So this is how generally things are handled in our package JSON. So like we have already seen how dependencies, how transitive dependencies are uh, maintained in the code. So uh, once we get a vulnerability, what happens? Vulnerability cycle. Whenever there is a vulnerability found in any of the package, maintainers release a new version, and Dependabot opens a PR. So if we are using GitHub Dependabot, it will directly opens a PR. We can review it and we can merge it. In this way, we can get rid of this vulnerability. But whenever we are not using Dependabot or we are not relying on that, we need to do manually npm audit. So it is recommended to audit our application every half yearly at least, so that we are not having any security issues. So let's discuss about what npm audit is and how we can do npm audit to make our application secure, to keep our application secure and vulnerability free. So there is a command in npm, like npm audit, which gives us a complete list, like what packages are vulnerable, what are the vulnerabilities, so if those are fixable with minor and patch release, or those are not fixable without any breaking changes. So like if I run this npm audit in this dummy project, we can see we have 15 vulnerabilities, out of which 3 low, 11 high, and 1 critical. So this report is always complete, like we can see if we have fix available or not. So we can see if we take example of loadless, we are having a fix available, but it is a breaking changes. So it is not showing us that it is not recommended to do any force upgrade, because there is a breaking change in the code. It will definitely break our code. So we should not do any force upgrade. We just need to do npm audit fix. So what this will do, this will only upgrade our minor and page version, which do not have any uh, uh, which do not break our code. Okay. So what I did, I have not saved it. So this caret symbol is stuck, and it was not picking the latest version. So let's run it now. Okay, so we can see it has upgraded our major and page versions wherever the fix is available, but it did not updated the JSON Web Token. Since the JSON Web Token, we have major update. JSON Web Token current version is 8.5.1, but the newer version is 9.0.3, which is having a breaking change. So it did not automatically upgrade. If we run npm audit fix force, it will upgrade the version, but it will not resolve the breaking change. So what is recommended? We should go to the package on npm side. We should check the documentation. What are the breaking changes? What are the methods which are changed? Is there any parameter changed? And which we are using. So first we need to check all those documents. Then we need to upgrade our package and fix the methods, fix the breaking changes which are introduced because of this upgrade. So this is the way how we can manage this vulnerability for the major version upgrade. We can upgrade one by one. We need to do testing also on this, and in this way we can achieve our npm audit. So let's discuss about the recent axios case study. What happened a few weeks ago? We have seen the axios released a new version 1.7.3, which was really vulnerable, which was not actually vulnerable in itself. The actually it is using follow redirect. That follow redirect is a transitive dependency of axios. As we can see, axios is using follow redirect, and follow redirect is vulnerable that time. What was the actual vulnerability? So it was introducing a proxy setup in the payload. Whenever the attacker can set the proxy in the JSON payload, which is coming from any of the UI or any of the request, and it can redirect it to a attacker's on site. In this way, attackers will get all the details about our data, and he can access our token, session token, and that can make our application really insecure. So this was the issue, and whenever if anyone deployed their application at that time and run npm install, it will fetch the version, and it caused their application vulnerable, and their pages were unreachable at that time. So what can be done at that time? So never, we should never use npm install. We should use npm ci. It will always fetch the package log, the version which is logged in the package log json. So first thing is that. Second thing is, from node 24 we have seen a new minimum age release strategy. So whenever a new version of any package comes out, it will not fetch the latest version. We can just add it by a config file in our code. In our code we can add a config file, and which in there we can mention the configuration, like we can add a cool down period, like we need to fetch the latest version after 30 days of release or 60 days of release. So the safest to adopt is 60 days of release. So it will be tested by other applications also, and the package is if there is any vulnerability, it will get identified, and it will fixed by the maintainers. So it is recommended to add this new minimum edge release strategy in our new Node.js applications, so that we do not get any vulnerable packages, and we can secure our application with this from these attacks. So next is, recently while working on this vulnerability fixes, I have found in one of our application was running from a decade. It was using a framework Restify. So this Restify framework is not maintained anymore from 2021. So it is adding a lot of vulnerabilities in our application. So what we have done, we have decided to migrate our code from Restify to Express. As we know, a framework is the most core part of our application. Whenever we think of changing a framework, it is like a huge task. Like we need to change all the middlewares, we need to check the routes, we need to do multiple testing. There can be multiple issues, like how we are getting the parameters earlier, how we are going to handle those parameters, how we are going to change the output. So a lot of changes were introduced when we changed the a framework from Restify to Express, or any framework. If we change in an application, the application is running from 10 plus years, so there are more than hundreds of routes, and the application was big. and simultaneously there is development going on that application, and at that time it is very hard to maintain, because whenever someone is also developing, he can add new routes with the old way, and we are going whenever we are going to convert, it will got multiple conflicts and break. So we cannot spend sprints and weeks to do this kind of things. We need to do as quick as possible. So with the help of AI, we achieved it in days. What we have used the AI to figure out what are the possible changes, what are the request and parameters changes, what are the breaking changes, and then we have completely used AI to migrate our Restify framework to Express. And AI really helped us a lot. It generated the code case test cases, and it also helps us in the breaking changes. After migrate, we did testing and we found some more issues, but AI really helped us to migrate it really fast in 1/4 time of actual time. So this is how we just migrated our Restify to framework to Express to resolve a lot of vulnerabilities in our code with the help of AI. So the migrations are like how we did the migrations. List every Restify specify API. So all the APIs are listed first. All the input, output, and parameters, how parameters are handled, all those are listed. We set up a next file along with it, and we created a dummy code first, and then we migrated from batch to batch. So, and at last, after the testing, we removed our Restify file, we removed our Restify package, and we have also upgraded Node. So basically, it helps us in upgrading the Node version also, and it keeps helps us to keep our application secure and vulnerability free. So this is how we managed to migrate our framework. So yeah, this is all about how we did the migration. And so basically, there are inbuilt tool. As we have seen, npm audit is completely free and inbuilt tool which we can use to figure out the vulnerabilities. GitHub also provide this dependable uh, and it can be configured with a particular master or main branch. And whenever we push any code on the our branch, desired branch, it will scan our complete code. It will scan each and every package. It will figure out which are the packages which are vulnerable, and then what it does, it always lists down, gives us a proper list of the vulnerable package with their transitive dependencies. Like if there is any transitive package which is vulnerable, it gives us complete nested tree that how our parent package is getting vulnerable. And there are other also tools: sneak, audit, ci, npm check, update, socket dev. So this tools are also good to check our vulnerabilities time to time. In this way, we have if we introduce it into our pipelines, we do not need to worry about getting extra tasks quarterly or half yearly and fixing all those. It will always run in at the time of development only, and we can anytime see what are the vulnerable things going on and how we can fix those. So this is all about security management and npm vulnerability management.